Today we're going to go over the study guide for our first Chapter 1 test. So all this vocabulary on this list here is what you need to memorize for the test next week. So let's go ahead and let's move down to question number 1. Graph the following on a number line with the indicated letter. So we're going to make a number line. I'm going to pause the video and I'm going to fill in the numbers for this number line. Alrighty, so now we have to label the following letters on a number line. So we have 3 with 2 bars between it. It's not 131, but it's the absolute value. Absolute value of 3 is 3. The opposite of minus 4 is 4. The absolute value of minus 7 is 7. And the opposite of minus 2 is 2. Let's move on to number 2. Order the following integers from least to greatest on a number line. Again, going to pause the video and I'm going to draw a number line. So let's start with A here. Minus 3. B. I had to add on 3 more. So I'm out here, so that's B will be out here. C is 0. And 3 is, or D is, right here. There we go. So ordering them from least to greatest, we have minus 10, minus 3, 0, and 3. Number 3. Write an integer for question 3. A profit loss of $50 minus 50. Gaining $20 plus 20 or 20. Number 4. Find the greatest common factor and the least common multiple for number 4. Use both methods we discussed in class. So we have 24 and we have 108. So I'll start by using the factor tree method to figure out my GCF and my LCM. So first I'll find 2 numbers that multiply together to get 24. These are our factors of 24. 24 gets smaller with factors. I'll continue to prime factor this because this is a composite number. So there are all my prime numbers for the number 24. Now I'll do the same thing for 108. 9 and 12. 9 times 12 is 108. I'll continue to prime factor these 2 numbers. And there we go. I'm going to go ahead and make a list. I'm going to list out all my prime factors of 24. Now I'm going to list all the prime factors of 108. And I want them to match vertically. So I have 2 2s. And I don't have another 2, so I have to leave a blank. I have 3 3s. Now I'm going to circle all my vertical pairs and bring those down. And that is going to equal 2 times 2 times 3 is 12. So my GCF is equal to 12. Now I want to find the LCM. So now I'll bring down my 2 and my other 3s. I know that 2 times 2 times 2 is equal to 8. And 8 times 3 is 24. 24 times 9 9 times 2 is 18, plus 3 is 216. So my least common multiple is 216. Common multiple and the greatest common factor. Use both methods we discussed in class. So let's start by using the factor tree method. Feel free to pause the video and try this on your own. So I'm going to factor two numbers multiplied together to get 14, or 7 and 2. 4 and 5 are two numbers that multiplied together to get 20. 3 and 10 for 30. We end up with 7 and 3 for 21. Now we're going to make a list. Okay, so now we're going to write out our factors. And we want to line up our vertical pairs. So be careful to line those up. Okay, and they're lined up. Now I'm going to draw a line just so I can see each pair where they're lined up. Okay, so I'm going to bring down all my numbers. Now, I look at this and I notice that every single number actually doesn't have a common factor because there would need to be 4. So the GCF is equal to 1. Now let's find the LCM. We have 2 times 2 as we bring down our numbers vertically, times 2 times 5 times 3. So we'll start off by doing 2 times 7 is 14. 14 times 2 is 28. And 15 times 28, 5 times 3 is 15. It's 140. 8, 2, 0, 2, carry the 1, we get 420. So the LCM, using the factor tree method, is 420. Let's do it another way. 14, 20, 30, and 21. We want to use the ladder method. 14, 20, 30, and 21 don't have a common factor. Therefore, we cannot pull out a number other than 1. But 14, 20, and 30 all have common factors, so we could pull out a 2. 14 divided by 2 is 7, 20 divided by 2 is 10, and 30 divided by 2 is 15. Then we simply just bring down 21. Now, again, all 3 of these numbers don't have a common factor, but 2 of them do. So we can bring down, we can factor out a 5 for 10 and 15. This will get us 2, this will get us 3. 15 divided by 5 is 3. Then we'll bring down a 21, and we'll bring down a 7. I see common factors still, so we have to keep going. Now, 7 and 21 have common factors of 7. So I could divide out a 7. I still have common factors of 3. Do you see here? These have common factors of 3. Now these are both 1, this is 2, and this is 1. Now, because it's the least common multiple, we have to multiply all the numbers on the outside. When I multiply 2 times 5 times do that backwards. Times 5 times 3 times 1 times 2 times 1 times 1. I get times 5 is 10. 7 times 3 is 21. That gives me 210. The rest are 1s, and 210 times 2 is equal to 420. So our least common multiple is equal to 420, and our GCF again is 1 because the only common factor is 1. Great. Let's go on to our next question. Recreate the diagram for the number and fill in the blanks. So I'm looking at here a prime factorization of 36. So what number times 4 gets you 12? That's 3. What number times 12 gets you 36? That's 3. Then that makes sense there. And what number times 2 gets you 4? And that's 2. Number 7. So we're looking at a birthday cake method here of prime factoring. 80 divided by 2 is 40. What number did they divide by, or what number did they pull out of the 40? And that's 2. 10 divided by 2, or 20 divided by 2 is 10. And there we go, we filled it in. So we have 4 2s and 1 5. For the following questions, I'm only going to solve these in one way. Again, pause the video and try number 8, and then check your answer. 2 of the lights at a local stadium are flickering. They both just flickered at the same time. One of the lights flickers every 7 seconds, and the other light flickers every 8 seconds. How many seconds until both lights will flicker at the same time? So we're looking for a commonality here, common interest. And are we looking for sometime way in the future? No. We're looking for the next second it happens. In the fewest possible seconds will they both flicker at the same time. So we're looking at finding the least common multiple here. So let's find the least common multiple of 8 and 7. What number can I factor out of 8 and 7? I can't. There's no number. Do you remember what you're supposed to do if you can't factor a number out of 2 numbers like this? You multiply the 2 numbers together. So then the LCM, or the next time the lights will flicker at the same time again, is it within 56 seconds. For football tryouts at a local school, 12 coaches and 42 players will be split into groups. Each group will have the same number of coaches and players. What is the greatest number of groups that can be formed? And how many coaches and players will be in each group? So we have 2 parts of this question here. Before we can answer the second part, we have to look at the greatest number of groups that can be formed. Greatest common factor, is going to tell us that we have to find the greatest common factor of 12 and 42. So I'll begin by drawing my birthday cake. What is a common factor I could divide out of 12 and 42? I can't think of one bigger than 2, so I'll go with 2. 12 divided by 2 is 6. And 42 divided by 2 is 21. Can I go any further? Yes, I can. I could factor a 3 out of the 6 and the 21. You get 2 and 7. Because I'm looking for my greatest common factor here, I multiply the numbers just on the left side. So my GCF then is 2 times 3, which is equal to 6. So what's the greatest number of groups that can be formed? and that is 6. So now I need to think about the fact that I have 6 groups and there are 12 coaches. What times 6 gets me 12? 6 times 2 gets me 12. Therefore, there are 2 coaches in each group. Next, we have to ask ourselves, 6 times what will get us 42? Six times 7 is 42. So therefore, there are 7 players in each group. So in conclusion, we can have two coaches and 7 players in each group. Daniel likes juice. Sam likes granola bars. Juice comes in packs of 6 and granola bars in packs of 8. If there are 24 players, what's the least number of packs needed so that each player has a drink and a granola bar that are none left over? I'm actually going to draw a picture for this question. So what I'm going to do is I'm going to draw juice boxes in groups of 6 and draw granola bars in groups of 8. I'm going to pause the video and draw these on my paper here. Okay, so now I've drawn 4 groups of 6 for my juice. This is grape juice here. And 3 groups of 8. Now I have an equal amount of 24. So I can buy 4 juice packs. 1, 2, 3, 4. 4 juice packs. And 3 graham cracker packs. 3 graham cracker packs. Because I was trying to get a total amount of 24 so everybody can get a juice and a graham cracker. And of course, you could have solved this in a different way. This is just one way to solve it. Anna and Donna are responsible for making the centerpieces on the buffet tables at a school dance. They have 6 dozen carnations, 80 lilies, and 64 rosebuds. All the centerpieces must be identical. Determine the greatest number of centerpieces Anna and Donna can make if they use all the flowers. So, I have 6 dozen, I have 80 lilies, and I have 64 rosebuds. I can't find the GCF of 6, 80, and 64. But what I can do is I can actually find the GCF, and notice how it says 6 dozen carnations. That'll give me 72 carnations. Now I have 72, 80, and 64. I'm going to find the GCF of that. I'm going to pause the video and find the GCF of those 3 numbers using the birthday cake method. So my GCF then is 8. So I can make then 8 centerpieces. 8 centerpieces. Now I have to have an equal amount for each type of flower. So that means that I need to have 72 total carnations. I need to have 80 lilies and 64 rosebuds. What times 8 will get you 72? 9. So I have 9 carnations for each centerpiece. 8 times what will give you 80? I have 10 lilies. 8 times what will get you 64? And I have 8 rosebuds on each centerpiece. There we go. So I have 8 centerpieces, 9 carnations, 10 lilies, and 8 rosebuds. Jehu saved all of his awards from school. He has 18 athletic awards and 27 academic awards. Jehu wants to display the two types separately in rows of equal length. Determine the greatest number of awards Jehu can put in each row. Then determine the total number of rows. So first I'm going to figure out how many awards he has in total. Actually, yeah, I'll put that on the side here, which is 45. Now, since it says greatest, that means I'm going to find the greatest common factor. So I have to find the greatest common factor of 12, of 18, and 27. I can factor out a 9, and that'll give me 9, 2, and 3. Since these are both prime numbers, I can stop there. My greatest common factor is equal to 9. So that means determine the greatest number of awards he can put in each row. He can put 9 in each row. And remember earlier, we said we have 45 awards. So how many total rows can Jehu have? Jehu can have 45 divided by 9, which is 5. Jehu can have 5 rows. Victor and Jake were having an argument. Victor says that absolute value is the same as finding the opposite. Jake says they are different. Who is correct? Explain the difference between absolute value and opposite. So, Jake is correct. Because absolute value is the distance from 0. And you can show that on a number line. And the opposite is on the other side, of a number line. Thanks for tuning in, and good luck on your test.